So today we're going to look at probability and tree diagrams, but we're going to focus on what the counting principle is and how it helps you find all possible outcomes. So the first one we're going to look at is a word problem. And within word problems, you want to find some keywords. So let's go ahead and read this together. Sarah had a skirt, pants, and shorts that she wanted to buy. She also picked out a t-shirt, sweatshirt, and tank, lists all possible outfits she can create. And that's just guaranteeing she would wear either one of each. So let's go ahead and create a tree diagram. And you did this last year in 6th grade, so this should jog some memories. We're going to use a letter to represent each possibility. So let's go ahead and see, using a tree diagram, how many possible outcomes we can have. So we have a skirt, pants, and shorts, okay? And then we're going to have a t-shirt, sweatshirt, and tank. So off of each one of these, you have a t-shirt, a sweatshirt, and a tank. I'll do a small A there. T-shirt, sweatshirt, and a tank. And t-shirt, sweatshirt, and a tank. I do a little TA to help me. You don't have to do that. You could use a lowercase t there if that helps you. It's really up to you. Okay, so we now can see all of our possible outcomes. So basically, our possible outcomes are listed right here. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9 possible outcomes. So if we were asked, we would say we could have 9 possible outfits. Now, there is a really quick way to find this, and it's called the counting principle. And the counting principle just says that you look at your events, and we have 3 possible shirts. I'm sorry, 3 possible pants, and you multiply it times the 3 tops. So whatever you have on each event, you multiply them, and you get 9. So that's the easiest way to do it. So if they just ask you how many possible outcomes can you have, you can use what is called the counting principle. You just take the amount of pants or shirts, the bottoms that you had, and then you multiply it by the amount of tops, and you get 9. And this is represented right here through a tree diagram. Okay, let's go ahead and do another example. So sometimes they're in word problems, and sometimes you get a chart. And this can throw kids, so let's go ahead and look at it. The students were given the options to pre-order a sandwich for their field trip. How many total options are available? This happens a lot when you're going on a field trip. The cafeteria will offer to make you a sandwich. They try to keep it as simple as possible. So they tell you can pick one from each of the options. So let's go ahead. We're going to start with meat. So let's go ahead and look at the meat. And we have turkey, ham, and tuna. I'll do a little U there. You can do a lowercase t if you want. We have cheddar or American. So I do a little tree off of each with cheddar and American. And then with the tuna, you do the same thing. And they only gave us 2 options there. And then off of each of those, we had mustard or mayo. Mustard, and I'll do an MA for mayo. Mustard. And you always want to make sure, like I did not do a good job at this, that you spread out enough, because that's what gets tricky. But for today's purposes, it's fine. Okay, so our, what we call sample space of all of our possible outcomes here are right here. That's how many possible outcomes. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and I'm missing one here, 12. 12. Sorry about that. And that's why you give yourself plenty of room. 12, which makes sense. We have 12 possible sandwiches. Well, is there an easier way if you're just asked how many possible outcomes? Absolutely. So let's go ahead, back up here, and use the counting principle, which says you take the amount of the first event, and we had 3 types of meats, and you multiply it by, we had the second event, which is 2 options, 2 cheeses, and then you multiply it by the condiments, which was 2. So you get 3 times 2 is 6. 6 times 2 is 12 possible sandwiches. So you can do it really quickly if you're asked using the counting principle, or you can use a tree diagram. Now, tree diagrams will be very useful tomorrow when we go into more specific probability questions. But if you're just asked how many possible combinations, you can simply just multiply each event times each other and get your total of 9 or 12. Okay, so hopefully this helped you. For today, we're just focusing on probability, tree diagrams, but specifically the counting principle. So good luck.